Today's date is um, the 17th of March 2026. The time now is 3 3 3:58. So basically, this video is gonna be on the Buffon needle and what's on the board today. Because this was done a long time ago now, we didn't do it. So let's go and do this properly. So, Namdi, this video is literally just recording, the baby recording my voice. This video is this video is on the Buffon needle and the theory of dark matter theory, or quantum field theory, and quantum field theory. So you have gravity, which is a weak force. It's so weak, it has no measurement. Gravity is a very weak force. So gravity is such a weak force, it seems there's nothing there. There's nothing there. So measuring gravity is like measuring nothing of something, something of nothing, or an eigenvalue. So what I'm doing in this board is explain this model as a Buffon needle of gravity. Gravity affects time, but it needs more mass to accumulate over time. So the more mass gravity has, the more model the system has. So what I'm saying here, so you got the Buffon needle, which is this needle, and something that's basically the model of the Buffon needle and gravity has an effect on the system with dark matter. What do you mean by that? So you have the Buffon needle experiment, which is the Buffon needle experiment, which is the Buffon bubble universe. This is the Buffon bubble universe. The Buffon bubble universe represents a much basically you got a non-Buffon universe, a non-Buffon universe. In the non-Buffon universe, there is you have to hold everything. You have to hold everything, everything, everything. What does that mean? Holding everything. So you have a space. Space is created. I can create space, but that's in a non-Buffon universe. We live in a Buffon universe. A Buffon universe is a Buffon needle universe where we have to create space. A Buffon universe is our universe, basically, our bubble universe. So our universe is called a Buffon bubble universe, and we live in a Buffon bubble universe. We live in a heterogeneous kind, which kind first, only kind first universe, homogeneous, which is a type next universe. We're in a kind of universe, a type next to. There's a kind of space and a kind of time. There's a type, then there's a type kind of there's a type of space and a type of time. What does this mean? In a Buffon universe, we don't need to create space. We don't need to create space. Time and space exist in parallel. Time and space exist in parallel. That's a Buffon universe. We live in a Buffon universe. Because if you have any kind of volume, like a cube, a circular volume, like a volume of a cylinder, which is pi r squared, base pi r squared times width times height. You have the radius pi r squared. So if you have a radius of 10, let's say you have a radius of 8, 8, 8 times pi, 8 times 3.1415, 8 times 3.1415. 8 is the width and equals okay. So you have pi r squared 3.14. Let me use a calculator here. So you have pi 3.1415 times 2 times pi r times r. Now r is 8 times 8 times 2. Let's say 8 units, 8 bits. 8 bits equals 1 byte times pi. Now 8 bits is basically for radius times pi r squared. times 8 times 8, which is pi r squared, which is basically not 8 times 2. Go right this time. You get this model. This is the beautiful universe. 3.1415 times 8 times 8 equals 64, uh, which equals to 20, 201. 201 is the cylindrical volume of the growth of the universe. So you have the base is pi r squared in area, and that is the area. Pi r squared equals to 8 times 8 times pi, which is basically 20, 201.1 centimeters cubed in volume of time of space. Now, this is a cylinder volume. I'm just drawing a system. 201.1 centimeters cubed in volume. If we're talking about meters. Now, let's use meters. So this is uses the meter, not the liters. So meters of volume. Now this volume represents the volume. This space has equivalent time. Time in physics. So mathematically, let's do something in a Buffon space. So in a non-Buffon space, in a non-Buffon space, this 201.1 meters cubed of volume has an uncountable equivalent to the set, a countable innumerable time equivalent in the system. Basically, you have the diagonal lining of space and time. If you have some kind of pi, pi over 2, pi over 3, pi over 2, pi over 1, pi over 4. And you have pi over 4, pi over 3, pi over 2, pi over pi over 1. You have the algebra model. So you're going to have pi over 4 times pi over 4, but you have you can't have a diagonal that matches the time, because time becomes uncountable, infinitive uncountable, basically model of revolution. So if you have pi over 4, so I was explaining that the needle itself is time or space, time to create space. And as it drops in the universe, in the 3D universe like our own, which is a non-Buffon universe, you have a homogeneous type only first relationship to a kind of relationship with the inverse notation. So via inverse, because the type is like a type of universe, because you have to have a type which is space first, a type, but it can be space or time, because space is time, but homogeneity means the same type or the same type before the homotype, not homocan, which is heterogeneous data, which is kind of relationship to a type of system. But the system is non-linear. The time exists on an axis. So we can model it properly using a balloon. Think of a balloon. A balloon. You inflate and deflate that balloon, and that universe imploded. So you have to be by holding space and holding time. I mean, you have to process that thing as using it. Like, my computer can only process space is a resource. My computer in a non-briefing universe, space is a resource. I can accumulate more space, more gigabytes, more terabytes to solve a specific problem. But because I can keep adding more space for every time, so if I keep to solve more competition problem, because space is free. Space is free. I can keep in a non-briefing universe, and in a non-briefing universe, time in a briefing universe, time doesn't exist. Time doesn't need to exist. In a briefing universe, you have to create that space to go into that system of time. You have to create that space. It's like me having no space and finding, because there's a ratio between part. The space and time are resources, and those resources are not free. Doesn't matter if I buy it or not. You have to compute it ahead of time to have it. So we live in a beautiful universe because we live in a time-only universe. Time is the only thing that's needed. Everything takes time. That's why time is linear. Time appears linear because everything takes. Everything takes a compute. You can't compute without it. You cannot deal without time in this heterogeneous universe. But in a Buffon universe, you can't do without space and time. You cannot do without space. Your computer has to allocate time and space to compute it in a computer system, in a computer sense. So you see this needle is basically dropped it's a Buffon needle. It dropped in space. But where does space come from? He has to compute it. He has to get himself to watch his space computer. So this needle has to drop in the space to pierce through the Bayesian system. But it's a linear system. It's even time or not. But, if this was less space and time, or space or time, this which it depends on how you use homogeneous model of space and time. So the booth. So as drops, in a vacuum it creates a space, and that's what we call space time. But we actually live in a time space. So our universe imploded. Basically, the what happened when I was listening was this thing: the non-Buffon universe imploded under its own creation. So there was so much space and so much time. The non-Buffon universe gave up and said, "Let me just implode myself," but it didn't break. So it broke apart because it imploded. It's like you drop into the water. Something exploded in water because and time was distinctly separate from space, and that's our universe. That's our Buffon universe. That's our universe. So this universe, our universe, why do you think so? Because there's a lot of space. I can create more space. Just open my hand. But where does space come from? I don't have to spend energy to do it. I don't spend energy. So this is it. I don't spend any energy to do it. E equals mass times constant squared is equal to gravity. Now that E equals mc squared. Now C is equal to gravity. But the constant of gravity is literally coming from the universe as a weak force. So the weak force of dark matter, again guys, the weak force of dark matter coming from the non-Buffon universe. Because the weak force existed before the strong forces existed. And the weak forces are things that we cannot measure because our frame of reference is we're drifting away. We're moving away from the weak force. We're drifting away from the universe. So our universe is expanding, but gravity holds everything together because there's no need to hold. All you need is a weak force, and that weak force is space. Is free space. And that's what's going on. So we held by nothing or something, which is the space that is already existed before us, that we don't have to hold. By hold, I mean we don't have to process it. We don't have to process space to use space. We should keep buy more teraflops of data, more terabytes, more keep back. Calculate as much space as we need to solve a first of hard problems. Because in bytes. And the bytes are heterogeneous homogeneous in our universe. They're heterogeneous homogeneous. And so because time comes from space and space comes from time. In this model, what is the theory of the model? So this is the dark matter theory because force equals mass and situation. And everything that uses force is a vector. Now I'll come to this later, but I want to say something. So you have imagine I'm just say now, it's basically continue. So you have imagine a spring. A spring has is an auxiliary vector. A spring is an auxiliary vector. If you have 5 kg of spring on a spring, have 5 kg of weight on a spring, the spring has to go down. So half of the kilograms will be, if you know spring physics, I don't know spring physics. Let me go. So the I times V times C. So basically the I K V. I'm busy, man. Don't come here and make a video, okay? How are you though?
Yeah, I'm good, thanks, mate.
Yeah,
Yeah,
good to be here.
computer.
Yeah, you can use it, mate.
Oh, mate, now I need to get off your work, mate. I'm staying with the bank.
Okay, so you're gonna have the formula for spring physics, and this is called auxiliary observer. And this is saying because the force of flow of spring physics would take the minus k, so the inverse property minus k, which you don't need to hold. You don't need to hold any negative quantity in our universe. You don't have to think about negative space or negative systems. Force is the restoration of a spring in newtons. K is constant strength of stiffness, and newtons equals to newtons per minute. Newton per meter. So for every meter, you have a newton. And newton is basically a force. So if you have a force, so this one is very important to understand. Is the difference. So if you have a force, actually spring of a spring constant K. K K is a spring constant, and spring constant is used to determine the energy potential of a system. So think of it this way. Think of it this way, guys. Think of it this way. Think of it this way. So you have two main things to understand here. Two main things to understand to just take away. So I'm just speaking for this here because it's very important to understand. So if you have the period of a mass spring is 2 pi times the square root of m, which is the m, which is the meters divided by k, the stiffness. The period of time t, well, for one full oscillation, is 2 pi square root of m k times k. You can understand power equals to energy times basically work done on a spring is equal to power divided by energy. And so let me give you an example. I'm writing it here now on my paper. So you have, so I'm using cylinder model of the universe to give you an example. But if I eliminate these problems, you can see what I'm saying. So I'm trying to eliminate space from the equation of time, because if space has if that means the solution exists in space they want to do it if you eliminate space. So the equation. So the Buffon experiment. I'm trying to prove my hypothesis correct. So you have uh, I can't show you my screen. Uh, Sorry guys. So you have uh work time equal to work divided by power. Time equals to work divided by power. That means power. That means power work time time power. The time is equal to the work divided by the power. Now work is equal to work done on an object. Basically, I'm trying to eliminate a system of basically work done. Uh, so work done is, I'm trying to find out work done because I've done work done in the system. Math is fun. How to calculate work, energy and work. So work equals to force times this times cosine theta. Now, work equals to work times distance, or force times displacement times cosine theta. Force, for example, if you have 200 newtons of force times 3 meters, you have times cosine 20 degrees, you have work done, and the work done is 200 newtons times 3 times 0.9397. The work done is 564 newtons per meters. But the work done in joule uh, in joules. So basically, the work done is a system of energy power to work, but you're gonna have work and power in relationship. But you're gonna have a system of equation. So if you have a time period t equals to 2 pi. So if you have energy, electric potential energy, Basically, you have two energy. You have potential energy, and you have elastic energy. So you have the system of elastic energy. So you get force constant. The force, the sum of variables. You're gonna have uh, the Hooke's law, which is basically half times k times x squared, where s is the basically the model I'm using to show this. If you have some spring and you have a 5 kilojoule, you have some 5 grams, 500 grams on the 500 grams of something, and that's things going up and down. So the up and down will be the oscillation, and the up and down will be oscillation, and you have the time period t. Now the time period for one oscillation is 2 pi. 2 pi is the period of time. So if you have half of 2 pi, you're talking about you're talking about 1 divided by 2 of pi, which is basically half of it. So the half will be pi divided by 2. 2 pi divided by 2 will give you okay, so basically, let's talk about the potential energy. So you have the ability to do energy, which is basically you. It's like elastic energy. You get elastic energy, you get potential energy. Elastic potential energy, and you get kinetic energy. So you get elastic energy, you get potential energy. So the U or EP or elastic potential energy is defined as half of K times K squared. K squared. Where K is the current spring. Current spring. So K is defined as the spring constant force divided by X, where X is the displacement or displacement of the force. Now X squared will be the U. So you get for example, so in this formula you get displacement. So if I'm talking about a spring of 5 kg, the displacement will be a vector position of down. Acceleration will be half of the force. So this force will be in half. So you're gonna have forces of a half of kg, because the energy to let go is a half. So you're gonna have a half a half or pi over 2, half pi over 2, pi over 3, and pi over 4, as the I can't remember this. But the goal is to have this trying to prove the Buffon model, because the Hooke's law allows for the fluidity of the elastic potential energy. So the time period, time and power ratio is T equals work divided by power, and the work divided by the power is because you get a time power relationship to work, and you have a system of let me just get the chat to prove this to me. So let me say, or I can get it here to do it to me for me. So I'm trying to prove that it's possible to have time and power switching to run in parallel, time and space to run in parallel to compute, so you can have more time in parallel, basically. And I'm trying to express that this power, time creates space, and space can be destroyed from time. Is just for time. So if you have a force times displacement times cosine theta, where theta is rotation of a magnetic system, you're gonna have theta cosine 20, 40, 50. That's work, but the work and the time are isomorphic. So you're gonna have a shared ratio of time via time equals work divided by power, and time equals work divided by power, uh, and and basically time divided by equals to power equals to a period of time, which is the capital T, 2 pi square root of m of the mass of the spring divided by k, which is time factor of the spring of time period. This we call a period, time period. or capital T. So these two show that the half and the kinetic energy receive astrobic and can be mapped to each other via a triangle put into the see what the air system says. So So basically, the version of Buffon energies is during those properties space time, the unit of time, the unit of space. So you got the unit of time, the non-Buffon universe. This is a non-beautiful universe. This is it's computation course. Must be created as an Edison parallel frame. A leader time is a Pearson emergent Reynolds, which acts as a water of the non-Buffon uh, theoretically. It's our universe. This one, non this one, non this one. So our universe exploded from the implosion. What I'm saying. So we live in a Buffon universe, guys. Thank you so much. So our universe, the whole universe, all three universes exploded. Our universe imploded because of it. So we just will quit our universe. Everything's drifting away from the universe. So everything is moving away from the universe via the drifter, which is basically everything moving away from us.